Hey everybody, welcome to the Pre-algebra 10.3 video, talking about area of parallelograms and trapezoids today. So again, what is a parallelogram? Well, remember definitionally a parallelogram has to have two sides that are parallel, and then the other two sides also have to be parallel, right? Okay, and what's a trapezoid? Well, a trapezoid can look like a couple different things, but definitionally it needs to have two sides that are parallel and the other two are not parallel. All right. All right. So first, let's talk about the area of a parallelogram. All right. So I'm going to draw us a parallelogram here. All right. And here's how I want to illustrate to you why we find the area the way we do. So if I took an invisible line and I cut that parallelogram right there, and I transferred what I'm now going to color in as a red triangle, what would happen is that red triangle would fit perfectly right there. And so now I'm going to outline our new shape in blue, and you'll see what we have is a rectangle, right? Well, how do we find the area of a rectangle? Well, we take the base times the height. So you know what? The area of a parallelogram, that's a bad parallelogram, is also going to equal the base times the height, okay? So let's say we had a parallelogram, and this will be item number 2. And let's say the base, 4 inches. The height, 2 feet. And I said, what's the area? Well, you'd say, oh, parallelogram, base times height, 4 times 2, 8 inches or feet. Oh, well, interesting. Got to change one of them, right? Okay, so I think it's easier to change feet to inches. We'll take 2 times 12, so that's 24 inches. All right, so let's take the base times the height, because again, area of a parallelogram is base times height. And so that'd be like saying, well, base is 4, height's 24. 4 times 24 is 48 times 2. You get what? 96. And we're talking about what? Inches. But keep in mind, the base was inches, the height was inches, so we were taking inches times inches, which gets us inches squared. And so there you go, 96 inches squared, right? But we can also use the formula for area of a parallelogram to find some other stuff as well, right? So let's say there's a parallelogram. Okay, and let's say it has a base of 3 feet, right? It's got a height of unknown, but we know the area equals 27 feet squared, right? The area is 27 feet squared. So we want to know the height. Well, how do we do that? Well, we know the area of a parallelogram is found by taking the base times the height. That's the formula. And even though we already know that the area is 27 feet squared, we can use that to help us find the unknown height. So what's the area? 27 feet squared equals the base, which is 3, times h, right? Okay, so, well, what do we do here? Well, 3 times h, got to get rid of that 3, so h is finally by himself. How do I do that? Divide by 3, divide by 3. 27 divided by 3 is, of course, 9, and we're talking about height, so it's 9 inches. So how tall is that parallelogram? 9 inches, which makes sense, right? Because 3 times 9 would get us 27. All right, so area of a trapezoid. Now let's talk about that. Okay, so the formula for area of a trapezoid is a little more complicated. It's nothing you can't handle. Okay, so area of a trapezoid, and again, this is just one way a trapezoid can look. It can look like a couple other things. We're going to take the height times the sum of the bases. Okay, so I'm actually going to have multiple bases, one there and one there. So the sum of the bases, we write that as b1 plus b2. Right, so base 1 plus base 2. And we're going to divide that all by 2. All right, so dividing that all by 2. So let's try one. Okay, so let's say we have a trapezoid, something like that. The height's going to be here. It's going to come off, it's got to be a 90-degree angle there. So let's say the height is 5. We're just going to use units in this case. Let's say that base, the top base is going to be 15 units. This will be 25 units. And what we want to know is, what is the area? Okay, well, let's see. Area of a trapezoid. It's found by taking the height, which is 5, times the sum of the bases, so 15 plus 25. Divide that all by 2. All right? So order of operations says, grouping symbol. Got to do what's on top first, then what's on bottom. So on top, we have to obey order of operations again and do what's inside the parentheses. So it's really like taking 5 times 15 and 25 would be 40, and dividing that by 2. Keeping with order of operations, got to do what's on top. 5 times 40 is 200. Divide that by 2. 200 divided by 2 is, of course, 100, but we're talking about units squared, or we're talking about area, so it's going to be units squared. All right, so I hope you did okay with that. If not, we're going to do one more here, and I just want to let you know I teach this formula a little bit differently than the book. I personally think it works out a little bit better. It's a little more easy to work with. If you don't like it, that's totally fine. You can do how the book wants you to do. You'll get the same exact answer. All right, let's try one more. Okay, let's say we're going to find the area. 9 meters. We'll do invisible dotted line. That's the height there. Okay, so 8.5 meters is the height. And let's say the other base is 3 meters. I want you to take a second, pause the video, try this, see what you find for the area of this trapezoid. All right, remember area of a trapezoid, found by taking the height times the sum of the bases. So I'm going to add base 1 to base 2 and divide that whole thing by 2. All right, so area of a trapezoid. Well, the height is 8.5 times base 1, which is 3, plus base 2, which is 9. Does it really matter if this one's base 1 or base 2? No, it doesn't. Divide that whole thing by 2. And so, let's see, order of operations says I need to deal with what's on top first. And on top, there's some parentheses. So I really need to take 8.5 times 12 and divide that all by 2. So if I take 8.5 times 12, you're going to get 102. Oops. And you're going to divide that all by 2. And 102 divided by 2 is, of course, 51. But what are we talking about here? We're talking about meters, and we're talking about area, so it's meters squared. All right, so we can also use what we know about trapezoids to find not just the area, but unknown lengths. Okay, so here we have a trapezoid. It's got a base. One of the bases is 8 meters. The other, the height is 6 meters. The area is 54 meters, but you know what? We don't know what this other base is. We'll call this base 2. Okay, we don't know what it is, but can we find it? Let's try. Let's use that formula. Okay, so again, we know the area of a trapezoid can be found by taking the height times the sum of the bases. Base 1 plus base 2, and then we divide that by 2. All right, so let's see, plug in what we know. The area we actually know this time, it's 54, and that equals, well, the height, so it's 6, times the sum of the bases. Okay, so one of the bases is 8, add to that the other base, which is, well, we just put B2, we don't know, so I'm just going to use the variable x, because we don't know, and again, we're going to divide that all by 2. All right, so this is where we need to have a good understanding of the distributive property. Okay, because order of operations would say, hey, you need to do what's on top first, then you got to do what's inside the parentheses. Well, 8 plus x. You can't add 8 to x, so you have to distribute correctly. Okay, so 54 equals, distributive property says I can take 6 times 8, which is 48, and then I can take 6 times x, which is 6x, positive 6x. Now we're going to divide that all by 2. Okay, so we got to get that x by itself, don't we? Yes, we do. So what is keeping the x from being by itself? Well, there's a couple things. There's a 48 being added, a positive 48 on this side. There's a 6 being multiplied by x, and this whole thing is being divided by 2. But the goal is to get x by itself. So how are we going to get x all by itself? Well, there's a couple things we could do. And here's my recommendation, because this is how we've done it in the past. You have a divide by 2 here. Right? And we know eventually we're going to have to get rid of that. So how do you get rid of a divide by 2? Well, you multiply by 2, and we can make that 2 over 1 if we want. But if you multiply one side by 2, you have to multiply the other side by 2. So let's do that. 2 times 54 is 108. And that's now going to equal, well, you have a 2 there and a 2 there. They kind of cancel each other out. So you're really just left with this numerator, which is Why we multiply by 2 is to get that numerator by itself now. So now we just have 48 plus 6x. The divided by 2 is gone. So now we just got to subtract 48 from both sides. Okay, so 108 minus 48 is going to get you 60, and that will equal, those cancel, 6x. So now we divide by 6 and divide by 6, and we are now at the end at x equals 10, and we are talking about meters in this case. So what does that mean? Well, it means up here, that unknown base right there is no longer unknown. Now it's 10 meters. All right, that's all I have for you guys. Look forward to seeing you in class, talking more about parallelograms and trapezoids.